I'm going to talk about electrolysis of a molten salt. For example, if you have lithium chloride and you want to make pure lithium, first you have to melt this. And then what happens is ions are mobile and free. And then we have to use electricity to push forward this sort of non-spontaneous redox reaction forward. That's why we have a battery. We have a minus electrode and positive electrodes, and these are your electrodes are made out of something inert, such as carbon, graphite. The negative is your cathode. It will attract the cation, which is lithium 1+, and it's by definition site of reduction. Now, I'm not going to do the voltage, how much electricity we need. I'm just going to do the oxidation reduction half for this reaction. So lithium 1+ liquid is going to gain 1 electron, goes through reduction to produce lithium liquid, and eventually the lithium gets accumulated here and you're going to drain it out of this cell. So 1+ lithium goes here. That's what we are interested in. Lithium is used for lithium batteries, quite powerful. And then chlorine, I'll just do it for sake of completing this half cell. Chlorine, on the other hand, chloride becomes chlorine gas by losing 1 electron going through oxidation at our anode. I'm going to show it in blue, and the chlorine is going to be produced as bubbles of chlorine. It's carcinogenic. Usually you have a funnel and you are going to also immediately drain it out. But we're not interested in chlorine. The next question is, what if we want you to calculate how much lithium you produce? For example, calculate the mass of lithium produced if you have current of 2 ampere for 20 minutes. There is one constant that is known as Faraday's constant, and it says in order to produce 1 mole of electrons, you need about 96,500 coulombs of charge is for 1 mole of electrons being produced. Now this constant is given to you. So every 1 mole of electron requires this much charge. Also, charge is calculated as current I times time in seconds. For our case, we have I is 2 ampere and the time is 20 minutes. So I'm going to multiply these quantities. 2 amperes multiplied by 20 minutes has to be converted to seconds. So I multiply it by 60. And once we do that, we have about 2,400 coulombs. Now, I have to see how many moles of electron I can produce with this much coulomb. Just remember the relationship on top. For every 96,500 coulomb, I only produce 1 mole of electrons. So if I have 2,400 coulombs, I can calculate how many moles of electron I produce. Let it be known as X mole. And when you cross multiply, you will see that X is 0.0249 moles of electrons. Now remember, lithium is 1+, so it only requires 1 mole of electron to produce 1 mole of lithium. So we are going to use this quantity and see how many moles of lithium we produce, which is obvious. But every mole of lithium requires 1 mole of electron. So if I want to know how many moles of lithium I produce for 0.0249 moles of electron, it's cross multiply, or it is 0.0249 moles of electron. We are almost there. Moles of lithium. Now we just have to find mass, and mass is nothing but moles times molar mass, or in this case, relative atomic mass. So I have 0.0249 moles We go to periodic table. Every 1 mole of lithium, its atomic mass is 6.94 grams of lithium. So that will give me 0.173 grams of lithium being produced. So for 20 minutes and 2 amperes of electricity, you are going to produce 0.173 grams of lithium. I will do one typical example using Faraday's constant on the next slide.